Hello, Honors Higher Algebra students. This is Mr. Johnson, and this is the 6th lesson in our Unit 16 study of statistics. And in this lesson, we're going to be looking at graphs of two variable data as well as the correlation coefficient. I'm doing this one a little bit different than the other ones because I really want to show you the calculator work on this, and I want to make sure that you understand how to type this stuff in. And there's not much I need to write on this particular lesson. A lot of this stuff is just to discuss and to type into the calculator. So we're going to start with the idea of correlation. And the idea of correlation is that you have two different sets of data, and you want to see if they are related to each other or not. So this particular scatter plot that you can see is weight and height of people. And obviously we can kind of intuitively think about weight and height, and oftentimes when somebody is taller, they weigh more versus somebody who is shorter. And of course that's not always the case, and that's why it's not a perfect correlation, but there's probably some sort of resemblance with regard to how tall someone is versus how much they actually weigh. You have this for all sorts of things. For example, with my students that are in calculus, when they get their grade at the end of the year in class, that grade really should be very closely aligned with their AP exam score. So in other words, if they get a 5 on the AP exam, they should probably have an A in the class. And if they get a 4 on the AP exam, they probably should have about an A- in the class. Obviously, that's not always the case. You'll have a student that has a C in class and they get a 5 on the exam, or even vice versa, but there's a correlation between their AP exam score and their grade in class. So there's lots of this kind of data out there, and we're going to be looking at this as well as how to make a scatter plot on the calculator itself. Okay, so here's an example. We have a local ice cream shop that keeps track of how much ice cream they sell versus the temperature at noon on that particular day. And so you don't have to think too much about this. The ice cream sales are certainly going to go up as the temperature gets warmer versus colder. That's why Dairy Queen in some locations of the country just close down in the winter because they just don't sell enough. And so this idea is not super abstract, but of course, when you look at the data, it's not perfectly aligned, but you can see that it has sort of a linear pattern to it. And that's really what we're going to be focused on when we talk about correlation. All right, so let's take a look at the idea of correlation and what's called this linear regression, which we'll be discussing in our next lesson. So as the temperature increases, the ice cream sales also increase, which again is pretty intuitive. That's called a positive correlation. Now this little chart here goes through all the different types of correlations. So we have a perfect positive correlation. That means it's a perfect line and it's increasing. High positive correlation, low positive correlation. So you can see that the data sort of pulls away when it's a low correlation. And obviously no correlation means there's really no pattern whatsoever. Now the idea of negative correlation just means that as one item increases, the other decreases. So you have this kind of linear pattern now that has a slope has a slope that's negative. Correlation is positive when the values increase together, negative when one value decreases and the other increases. So how do we determine the strength of this linear relationship? How do we determine if it's a positive correlation that's nicely aligned versus a kind of low correlation? Well, it's called the correlation coefficient, which is R. And thankfully our calculator does this for us. Here are some properties of R. So we have the measures of the strength of the linear relationship between two variables. So R is our calculation we're going to refer to. R is between -1 and 1. If you have R equal to -1, that is a perfect negative correlation. If R is equal to +1, that is a perfect positive correlation. If there is no linear relationship, so the data is just sort of everywhere, that means R is 0. And then again, the sign of R determines the direction. So whether or not the pattern is linear and increasing or linear and decreasing. All right, there's lots of stuff here, but really what it does is it just defines what R is and what it tells you. So if R is 1, I had mentioned already that that's a perfect positive correlation. That means a perfect line that is increasing. -1, that would be a perfect negative correlation. And so then you have all different ranges here, okay, of R. And again, R is anywhere from -1 all the way to 0 with absolutely no correlation, all the way to +1. And so those are our values of R, and you can see the graphs that sort of pertain to the different values of R and what those would mean with regard to the type of correlation and the strength of the correlation. There's lots of formulas for R, most of which are quite intensive, and you see this little sigma here again, and I talked about that. You won't really understand that fully until calculus. Thankfully, our calculator will do this for us, so we don't have to worry about doing any of that by hand, but you can see the equations are quite complicated. All right, so here's how you do this, and that's one of the reasons I want to have my calculator here for you all. So let's go to Stat. So we'll go to our Stat button, and we'll go to Edit. So number 1 there, and we're just gonna put in some data here. So let's just put in some random stuff. We'll keep these values kind of small like this. I'll just put in just a little bit. And then over in L2, so list 2, we're going to put in some other data. Let's do, I don't know, like 51 and 50 and 50 and 48. I have no idea what this data is representing, but that's okay. All right, so there's our data. Now, if you have ever gone to your y equals and you've seen one of these plots highlighted, those plots are actually going to be the way that we sketch these things. So for example, if you were to go up to the plot 1, you could hit enter, and on your graph, now what I'm going to do here is I'm going to change my window because my x values were between 0 and 10, and I made really big y values here. So let's see if we can just make this 0 to, I think I was in the 50s, so let's do like that. And we'll graph this thing, and it's not very entertaining, but you can see that we have little bits of data. Remember I put in 5 of those, and so this is going to be L1, and this is L2. We're going to talk more about this, so don't worry too much about that if you kind of lost it. But I just turned on my scatter plot basically, and it just gave me this little bit of information, and it does kind of look like it is a little bit linear. I mean, I would say there's I guess there's a little bit of a correlation there, and it seems positive, right? But anyway, that's the idea behind this. And so to calculate R, to try to figure out if R is again positive or negative or 0 and that kind of thing, we're going to go back to our home screen. So go second and quit, and then you're going to go to your mode. And you can do it this way as well over here on the right, but I'm going to do this in mode. So you can go to mode, and you can go over here to Stat Diagnostics and turn that on. And what that will allow us to do is calculate this R. Okay, so I'm going to press second quit again. We're going to go back to the Stat menu. We're going to go over here to Calculate. And option 4 is called a linear regression, which we will discuss in our next lesson. But just make sure that L1 is in X. Remember, we talked about that already with the graph just a second ago. L2 is in Y. You don't have to worry about those right now. And then just hit calculate, and don't worry about anything here except notice that we have R. And so it looks as though we have a pretty strong correlation because it's relatively close to 1. And certainly it's positive. We sort of saw that in the graph, right? I mean, it looked relatively linear, and it looked like it was increasing. And so we are sort of confirming that the correlation there, I just deleted it, so let me go grab it again. The correlation R is 0.824, which again is pretty close to 1, which is the maximum or most perfect correlation. Okay, so we're going to go to this ice cream shop thing, and we're going to try to figure out if there's any kind of correlation there. We did notice that it seemed like it, so we're going to go to we're going to go to Stat. We're going to go to Edit. I mentioned this in a couple videos ago, but you can go up to L1 and press Clear and hit Enter, and you go over to L2 and press Clear and hit Enter. Don't ever press Delete, because then it just gets rid of it. And then we're going to type these in. So we'll have 14.2 and 16.4, and I think I'm just going to pause and finish these off. Okay, so hopefully you have all your data in. So I finished L1, which is the temperature, L2 was the sales. And then I did mention if you go to y equals, you can turn on your scatter plot up there. You can also turn it off, just so you're aware. You just hit enter and turn it off. Let's go to second and y equals, because this is a more extensive menu. So you can go to your plot 1 and hit enter, and this way you can turn it on. You can actually choose the type. I'm going to use this first one, which is all those little pieces of data there. That's a discrete set. It's a scatter plot. You can choose your X list, which I'm going to use L1, my Y list L2. If you ever want to change that, you can press second and any one of these L values right here, from 1, 2, 3, 4, 5, 6, you can choose. You can choose how it looks, like a little, I don't know, square thing or a plus sign, or you can choose the color. It's all that kind of stuff. And then we're going to have to go to our window because our X values are actually between, let's just say the minimum is about 10. That's our temperature, and then our maximum looks like in the 20, so I'm going to say like maybe 25, I think we'll capture all of it. And then for Y, the minimum could be 0, but I think what we'll maybe do is just make this, let's just do like maybe 200, and we'll make a maximum of, let's say, 650 maybe, and see if we can just capture everything within there and hit our graph, and you can see our data, and you can see that correlation. In fact, I think I might make that Y minimum maybe 100, just so we can see a little bit better. There you go. So you can see that it is relatively linear. It looks like it's obviously positive, it's increasing, and it looks like it's a pretty good correlation. So what we're going to do is we're going to find the correlation coefficient for that. We're going to go second and quit. We're going to go back to our home screen so we don't mess anything up. We'll go into stat, go to calculate, go down to option 4, make sure L1 is X, L2 is Y, forget those for now, calculate, and there you go. It's actually in a very, very high correlation, 0.9575, so very close to +1. And we can see that visually. That makes some sense to us that, all right, that's relatively linear. Okay, so what you're going to do now is you're going to go ahead and complete some of this homework, and we will talk next about the equations for this line and that type of linear regression in our next lesson. Thank you.